So this is the fourth module. What we are going to look at quickly, maybe next less than 30 minutes, vulnerability assessment, some practical things. Most of the things we are talking is standards and best practices. Then we will briefly discuss NIST compliance. Then associated thing is NIST grid exercise, very much relevant to industries. Then some of the cybersecurity best practices. So vulnerability assessment, it is a process as we discussed. You have a system which has a network, devices, servers, systematically looking at or analyzing each one of those elements for vulnerability. So there are tools available for vulnerability scanning, cryptanalysis, software first testing. There are standard methods, standardized methods are available to conduct this kind of process. Some of the common tools, Nmap, a security scanner to discover hosts and services on the network. Like I was kind of mentioning, even now here on the right side, a typical intruder go through this process, footprinting, scanning, enumerating, and exploitation. But the same tools are designed to be utilized by the system security professional for securing the system. So the tools are same. The security professionals use the system for discovering vulnerability and protecting the system. On the other hand, the adversaries use it for exploitation. So Nmap, a security scanner to discover hosts and service on a network. Wireshark, a packets sniffer and analysis tool, what type of packets are flowing through the network between, let's say, control center substation or within the substation or between two control center. What is the format of the packet? What is the IP addresses of the endpoints? All those things we can analyze using this packet sniffing tool. Nessus, a comprehensive vulnerability scanning program. There are other programs like this. What it does is the database of vulnerabilities that are there, it will consult those databases and see whether the targeted system has any of those vulnerabilities. If one or more vulnerabilities are there, then it will report and it will give sort of what vulnerabilities are found and level of severity and things like that. So that is for vulnerability analysis. So the steps, what is listed there, these three tools can be used to go through these steps, like Nmap for scanning purpose, Wireshark for analyzing the packet, Nessus for exploring vulnerabilities, then you do the exploitation. So this is a typical screenshot of Nmap tool. You can specify Nmap with a target IP address. There are so many options one can specify. Then it will kind of list all the specific information about the host or all the hosts that are present in a subnet. Those kind of information can be obtained, which can be used to take it to the next level for Wireshark, Nessus, those kind of things. The Nessus, which is a vulnerability assessment tool, wherein what it does is it consults the vulnerability database, known vulnerability database, and determine whether this targeted system 192.168.5.210 what vulnerabilities are present in those systems. That is what the Nessus does. Then at the end it will give you a summary report. So this process can be done for, was discussing about the vulnerability assessment. For that, different tools are there, Nmap, Wireshark, Nessus, to do different things like scanning, network. Scanning, network analysis, traffic analysis, and actual vulnerability assessment itself. Okay, so this is the vulnerability report from NIST. If you run this analysis using specific host, it will kind of look for known vulnerabilities and kind of grade them, high, medium, low kind of severity level, then it will give a report. Then with respect to vulnerability itself, it has a life cycle. When it is created, when the designer built a system during design or development process, then it is discovered at a later time and notified to asset owners to this is happening, there is a vulnerability, then the mitigation or patches release, then it is actually applied. So this is a typical process. We would like to make sure there are no zero-day exploits. That means the moment vulnerabilities are there, they have to be patched as soon as possible. So there are some discussion about there are different people have different interests, like stakeholders, researchers, they are interested in finding vulnerabilities, vendors are interested in so vendors, they develop products, customers, they use the products, then the government agencies, they try to make sure those various compliances and vulnerabilities are disclosed so that those patches are updated. So there are different challenges there. In the interest of time, I will skip some of them, but you can kind of read. There is a paper there. You can read that paper. It's listed at the bottom. The challenge is each one has different interests. When there are vulnerabilities disclosed, do you disclose immediately or you don't disclose it? There are pros and cons. So that's where there has to be a notion of full disclosure. It has its own advantage, pros and cons. Similarly, non-disclosure, it has its own pros and cons. Limited disclosure, which means it's a methodical process where whenever vulnerability is discovered, the vendor is notified. The vendor basically acknowledges, then they come up with the mitigation and let the asset owners know, and they are applied, not going and telling the world. Then it is probably known in the public. I think that is the kind of policy much more attractive, limited disclosure, compared to either of the other two extremes. Like full disclosure means sometimes before patch becomes available, the adversary comes to know, oh, there is a vulnerability, but patch is not yet available. So that is a full disclosure, it's not good. Non-disclosure, that means it is a false sense of security. Oh, nobody knows, only we know it. Let us not do anything. That is also not good. So every vulnerability needs to be disclosed, but that disclosure will happen to the right people and patch has to be done. Then beyond that, it could be shared to the public. So these are some of the time cycle involved. Creation, discovery, vendor notification, mitigation release, mitigation applied. So non-disclosure, the time duration is very short. Full disclosure is very long. Limited disclosure is somewhere in between, because from the notification time, actual patch mitigation upgrade or update, that is the time it is exposed. So which means non-disclosure may sound good, but sometimes patch may not be even created. There is a false sense of security. So how do you force the vendor to create patches? Still they are notified to the utility asset owners or any owner of the assets, and they are applied. So limited disclosure is a kind of good industry practice. There is a way to do it. There are some documents in the federal government how to go about doing it. Public, each vendors, they have to have public vulnerability management page, and they have to notify the public. Before that, they may have internal processing to take care of patches and in a confidential way informing all those stakeholders. There has to be defined time frame for doing all those things, not arbitrarily those kind of things. So different vendors have different kind of policies in place. The open source community, IT vendors, automation vendors, and of course the government entities, they have their own requirements. Where it is in the web page, you have to have public disclosure policy page, how it is done, especially for vulnerability disclosure. What type of disclosure method, limited or full, especially in the open source, it's kind of whenever vulnerability discovered, they just disclose it. Whereas in other kind of situation, they are more responsible. That's why they are limited. Vulnerability management page, and what is the time frame within which these are all controlled, managed. These are all still best practices, not enforced yet as a law or anything. And also security advisory, like Microsoft every month, they issue a security advisory, same way other organizations do as well. There are also some incentives. If somebody find vulnerabilities, they are given monetary incentives, especially big companies, Google, Facebook, they all incentivize people to find vulnerabilities. Before going to the adversary, give it to us, we will take care, fix it. So those things happening. But the challenge is when you think about SCADA, ICS environment, we are not all dealing with, not only dealing with IT equipments, but also industrial control system devices, protocol, software, they are somewhat different. There are two industries come into picture, especially critical infrastructure. One is traditional IT industry, another is the automation industry. They all coexist as part of this critical infrastructure environment. So coming up with a common policy and working relationship is a lot more challenging compared to working with one of those industries. So there is ICS CERT advisory for disclosing vulnerabilities. This is maintained by Department of Homeland Security. All the vulnerabilities that are discovered and reported, they are all maintained there. They also give advisory about how to manage those vulnerabilities like patches and so on. With respect to energy infrastructure, there is something called NERC ES-ISAC or EISAC, Energy Information Sharing and Analysis Center, which facilitates sharing of information pertaining to physical and cyber threats, vulnerabilities, incidents, and potential protective measures and best practices. These are all part of the NERC. Especially the utility industry uses this particular organization very well within the NERC. For all other critical infrastructure ICS system, the ICS CERT is used. For general IT system, it's called CERT. So typical CERT advisory, that is what listed here. What are the affected products, what impacts, what is the nature of the vulnerability. Then they provide a description about the vulnerabilities and difficulty level. Then they also give a score, and at the end they give you how critical that vulnerability kind of score. Then at the end, how to mitigate those vulnerability, including patches and things like that. So this is sample ICS CERT advisory for a specific product, overview specific product, what impact it can cause, and other piece of information. So just moving forward, cybersecurity standards. NIST IR 7628 is one standard. NERC is another standard. There are several other standards that exist from IEEE, IEC, NERC, and other places, FERC and things like that. So I will just pick out two of them. One is from NIST. NIST IR 7628 is a cybersecurity framework for smart grid. It identifies research issues and also standard development issues, interoperability, cybersecurity standards, and things like that. From a research perspective, it covers AMI, PMU, the wide area monitoring, control application, communication protocol, cybersecurity, electric vehicles, those kind of things. Within that, there are 3 volumes. This is what it is. If you have not seen this, it's a good document read, but it's a big document. But there is an executive summary which is much shorter, that is quick to read and get a gist of what is going on. It provides cybersecurity architecture high-level requirements. What are the CAA properties, confidentiality, integrity, and availability properties across different elements within the substation, between substation control center, between control center, all kinds of things are well defined. What are those communication flows? What kind of security properties needed, access control needed, key management, cryptography, all those things. Some of the things we talked this morning, they are all discussed in the context in terms of requirements. Risk management and risk assessment, that is also important component that is addressed in volume 1. Then privacy and the smart grid, like consumer data and other things, laws and regulations concerning them. Those are all defined in volume 2. Volume 3 is about vulnerability analysis, security architecture analysis, and how do you each individual element, how they are secure, infrastructure security, like device security, network security, system security, those kind of things. So the top one is the requirements, the middle one is security and privacy, laws and things like that. The bottom one is network security. Those things are there. This is the kind of use case diagram they are given, operational diagram. You have use case analysis for your system security architecture, for system use cases, do a risk assessment from your point of where the vulnerabilities and other things, threats and impacts. The privacy requirement, you define your high-level requirements. Based on high-level requirements, you define your architecture in compliance with some standards, then check your architecture for conformance. So typically, if you are architecting a new security architecture for your environment, kind of go through this high-level model, what your threats and assessment, vulnerabilities, where your boundaries, any privacy concerns and other things. Define the security standard that is compliance with some existing standards like CUSP and so on. Then there has to be conformance validation. So the next important thing is NIST standard. It focuses, it is primarily applicable for North American electric grid. It focuses on physical, cyber, and operational security for bulk power system, primarily for bulk power system. It has several things: identify vulnerabilities and countermeasures, deterrence, prevention, detection, correction. Some of these things captured there. Storage, data security is very important. Physical security is important, and network security like electronic security perimeter, training, and other things. So it is essentially not about technology, process, and people. All three are important. Technology, process, and people, like I mentioned before, in a holistic way, it tries to establish a baseline for security in bulk power system. Of course, just NERC compliance means satisfying NERC compliance doesn't mean that the system is secure, but at least it is secure at the minimum level. Most of the organization, they go far beyond NERC compliance for securing their system. So this is NERC 5, but now we have 6 or I think 6 or even more, 6 probably. It identifies the system into critical cyber assets, the critical critical cyber asset, medium critical cyber asset, or non-critical cyber asset. Any cyber asset that is tied to critical operation of the grid, that is called critical cyber asset. Identification of those critical cyber asset, and with that categorization is CIP 002. Security management control is 003. Personal training is 004. Electronic security perimeter, like defining firewalls and other things to put all critical cyber elements, critical cyber assets are within the perimeter, that is 005. Physical security is 6. System security management is 7. Incident reporting and response planning is 8. Recovery plans, how do you recover the system in case of contingencies, that is 9. Configuration management, like patch update, periodic vulnerability assessment, those things, number 10. Then protecting data, data security, information protection, during storing, transmission, and accessing, all those things at 11. So it's a long document is there. within which there are subcategories, but this is the general gist. I will quickly flash through on each one of them. To identify critical cyber assets, there is, as I said, high, medium, low impact critical cyber assets. Some cyber asset is like control center. It's very important for the grid operation, so it is definitely a highly critical cyber asset. Some specific device somewhere probably may not be highly critical cyber assets. So that's the kind of classification. So the high impact critical cyber assets, anything based on balancing authorities, control center, transmission operators, these kind of things, high impact critical assets, medium impact critical cyber asset, and low impact critical cyber asset. So what it means is anything high impact or medium impact, they have to follow certain cybersecurity control requirements. Low impact, they don't need to necessarily follow that requirement. So the expectation is the high and medium impact categories are combined together to achieve certain things. Then security management control, so it is all refers to, is there an individual called CIP manager responsible for cybersecurity of the utility environment, how often this document is updated, personnel training, electronic security, everything related to what needs to be done in terms of technology, process, and people. Do you have a plan in place, and who is in charge, responsible for that? And this plan has to be updated every 15 months or so. That's what it is there. That is management control. Personnel and training, security awareness, cybersecurity training, personal risk assessment, whether this individual is a risk to the organization, insider threat, those kind of things. Access management to critical assets and resources, who is allowed to go even into a control center. All those things part of the personnel and training, including cybersecurity training. Physical security of critical assets, that means they are protected, they are locked, physical security plan, they are monitored, visitors control, and there may be surveillance, those kind of things, access to different key access mechanism to get into the physical location, those things. Cybersecurity management control, which is port services, patch management, malware prevention, security event monitoring, log management, access control policies, all those things. These are mainstream cybersecurity requirements, systems security management control. There are a lot of software tools are there to facilitate this kind of functions. Then incident reporting, if some event were to happen, what kind of reporting, what kind of follow-up step needs to be done, incident reporting and response planning. That has to be worked out and it has to be reported periodically. Then recovery plans, that is important. Configuration change management, changing the system, updating the system, patch management, they all have to be tested within the testbed environment before actually implementing in real system. All those things are important as well. Information protection, any information, critical information, classification information, protecting information, storing information in secure place, transmitting the information in secure way, and even destroying the information in a secure way. Those are all extremely important. So those are some of the 11 things that is part of the thing. Right now, some cases, synchrophaser may be considered as a critical cyber asset. If that is the case, all those security requirements for critical cyber assets of high or medium level will apply. If it is not critical cyber asset, those things don't apply. One is called electronic security perimeter, something like you have all the critical cyber elements, they are inside the electronic fence, like a perimeter. Essentially, they are not exposed to the internet directly. There are firewalls around that. If you get into this HMI, you have to go through a firewall or gateway. You have to get into this one, there is a firewall. So there is no way you can get into any one of them without going through the gateway or firewall where those security is enforced. So if anything that is let's say some device PMU, it's not part of the critical operation, it's only used for monitoring purpose, not for control application, then it is not a critical cyber element. It doesn't come inside the cyber perimeter fence. It could be outside the fence. So we were talking this morning, sometimes the compliance is too severe, people, the industry is so concerned, sometimes what they tend to do is, oh, some critical element is there, let us not disable it so that we don't need to consider as part of the compliance requirement, put it outside the perimeter, because the requirements are so severe, sometimes it is counterproductive. So there are challenges, especially dynamic threat landscape, and the compliance keep changing, and the industries, by the time they finish satisfying the current compliance audit process, the next version is coming. Then they have to constantly working. It is a challenge, and there is a lot of resource commitment needed. So some of the things in the past, it was there. In the future, PMUs, and depending upon some utilities they use for real-time application control, real-time control applications, then it goes inside the perimeter. The perimeter security is number 5, I believe. 5, that is part of the SIP compliance, and the firewall configuration appropriately to make it happen. That is the implementation. As we talked about the Ukrainian grid, when it's a coordinated attack. But the point here is, if SIP-like compliance process is in place, how these things would have helped. One is like security awareness and training that would have prevented this spear phishing attack. That is the starting point. Somebody clicked a PDF file. That should have been avoided. If that were to happen, if there was a proper monitoring and logging of events, that is somebody scanning, somebody left a log, that would have detected, okay, that is going on, because they took 6 months to really, as part of the reconnaissance phase. The other is two-factor authentication. When they are trying to steal VPN credential, the VPN credential is stolen. When they are trying to log in, if there was a two-factor, they sent a code to your mobile phone, then you would have detected, okay, this is somebody is trying to access into your system. So we all the time we get those kind of notification. If you are in Apple or Google, you get those kind of notification. Two-factor authentication would have prevented this VPN credential, stolen VPN credential, exploiting that for access, getting into the system. Remote access, why someone from remotely able to even get access into your network, internal network, disable all those remote access services, RDP, remote desktop, all those kind of things. So there are so many things. If you look at, except the bottom 3 are technical nature. The top one is more training and awareness in nature. Of course, one or more of these things, if they were in place, they could have prevented such an attack. Of course, one could argue if such a things were in place, the attacker would have figured out some other ways to still get into the system. So, but the point here is there are well-known security measures that can be put in place to secure the system, at least to reduce the probability of being targeted and compromised. So just relate to what we are talking, NIST compliance. That's what we talked about, how it is related to these things. NIST compliance, multi-factor authentication. The latest thing, NIST 6 has multi-factor authentication, two-factor. In the past, it was just not there. After all these things, two-factor or multi-factor authentication, if we have, then the adversary would not have get into the VPN login into the OT network. That should have been, that would be prevented. So two-factor authentication is one way. Then deploy methods to deter, detect, and prevent malicious code. That is like deploying malicious code inside your control environment. Why a code is downloaded and allowed to run? There is a SIP compliance which ensures, or if it is fully implemented, such a things would be prevented. Then mechanism to detect malicious communication. Why some sequence of things, let us say, trip this, trip this, trip this. In normal operator won't trip that many breaker at the same time. If there is a way to detect that, then there is something is going on. So the point here is the 3 to 6. Those are the steps in the earlier diagram. What I showed, 3 to 6, which were in the OT network. We are not talking about the end user making mistake, but all the technology kind of solutions, they could have been prevented if NERC SIP-like compliance process is in place. So the other one is the NERC grid exercise. They do it every 2 years in October time frame, just to verify and validate the cybersecurity preparedness in the whole North American region. It's a tabletop exercise, as if some attack is happening, find out what are the security preparedness, are there any loopholes, how communication between various entities, are they working, security planning is in place, those kind of things. That exercise being regularly conducted. Grid exercise 2011, 13, 15, I think there is 17 just happened actually in October. So this is part of the NERC SIP compliance, grid exercise, then grid security conference. They have multiple things as a package program, then information sharing and analysis center. So that is the nodal agency in the North America for coordinating cybersecurity for the utility infrastructure. So those are some of the things. I don't want to get into grid exercise itself. It is a series, biennial physicals and cybersecurity to validate current readiness of the electric industry to respond to cyber incident and provide input for security improvement programs, exercise NERC and industry crisis response plans, identify gaps in plans, security programs and skills. It's not only technology, it is technology, process and people, everything. Assess and test, validate existing command, control and communication plans for key stakeholders, identify potential improvements in physical and cybersecurity plans, programs and responder skills. So this is the overall goal or objectives of this grid series. This has been going on successfully. From every exercise, they learn something, then they try to incorporate into the next edition and improve. It is a public-private partnership. Everyone is involved. They define the scenarios. It goes on for months, defining those scenarios, and the actual exercise happens for 2 days or 48 hours. Then they kind of inject some surprises during the normal scenarios and see how things, the utilities are responding. It is a tabletop exercise. It's not like a malware is sent. They will send a notification email saying your system is under target with the malware, your substation is down. They will try to create a scenario, explain those scenarios, then they will see what reaction you have. That's why it's called tabletop. So there is a lot of things they learn from it. One of the important thing is information sharing could have been better. Things like coordination with the NERC could have been better. How do you deal with the coordinated attack? One attack they are good at dealing, but when there are multiple things happening, sometimes they don't know what to do. Those kind of things they learned, and there are improvements made subsequently into SIP compliance and their awareness program and other things. So it's a tabletop exercise, and also they have a conference, which is a grid security conference. All the industries, they go there. There was an earlier question, where do they go for all this help? This is the place they, as a community, they'll kind of share knowledge and leverage expertise and address the problem in a holistic way. So some of the cybersecurity best practices from other sources: defense in depth. We talked about protecting network boundaries and protecting the host or environment itself, like firewall intrusion detection on the boundary level. Inside the network, whatever servers or hosts that are there, operating system, application, patch management, vulnerability scanning, all those good things, they have to be done. These are some of the best practices from DHS US CERT. They are broadly applicable for any critical infrastructure. They are equally applicable to electric power grid. Only thing is you don't want to scan the live system in the electric industry. Though some of the things are prohibited, but in a broad sense, those policies apply. Minimize network exposure to, like said, don't let any critical cyber asset face the internet, so that Shodan kind of tool can pick up. Avoid that. Put them inside the electronic security perimeter so that they are not exposed to internet or outsider attacker. Isolate the network, IT network and OT network as much as possible. If they have to share, then put the proper guards in between, and that means the electronic security perimeter. There are different ways to do it so that there is some notion called demilitarized zone. So there is information has to be shared between IT network to OT network. Then put the information into demilitarized zone, DMC. Via DMC, you share the information. Don't allow direct exchange of information. Those are some of the best practices. Account lockout, somebody keeps trying, okay, then lock out the account for some time. You throttle the attack behavior. Password management policy, change the password regularly. Access management policy, you are all allowed to access what pieces of information. Review it periodically. Don't let it go. Don't assume that it is automatic. Secure remote access to VPNs, not just simple access. Two-factor authentication, patch management policies, those are some of the things. Protecting network boundaries, I think I mentioned. Protecting computing environment mentioned. Just to wrap up, I think defense in depth, I think it is very important. From information security, from the infrastructure security like network infrastructure and other things. Information means encryption, authentication, those things, and also the application security, the actual applications, whether related to energy management, distribution management, or substation automation. All those applications has to have inbuilt security. Then when you have all those different layers of security, you have defense in depth. So your actual core is here, but somebody sitting here, they can't come in. There are different layers of security that is in place. Again, just to recap, just to protecting the bulk power system transmission infrastructure alone is not sufficient. We need to secure the substation infrastructure in the distribution side, feeder side, and other places. It may not be the same level of security enforcement, but security is end-to-end issue as opposed to just meant for only bulk power system. So just to summarize what we discussed here, vulnerability assessment tools, or the process and tools. Then I briefly mentioned about the disclosure policy, responsible disclosure policy. If somebody discovers a vulnerability, notify the vendor first, then work with the government agencies. Don't publicly put it in the public domain. So that is called responsible disclosure policy. There are some variations of those things, but the point here is work with the responsible people so that right things are done. Cybersecurity standard overview, I kind of talked about the NIST IR document and NERC SIP compliance. That's very, very important. And NERC grid exercise, which is part of that overall program. Then at the end, whatever I showed, some of the best practices, they are coming from DOE and DHS. I think that is the end of my presentation, formal presentation. But the key here is throughout this presentation, I kind of referred documents from various sources, from NIST, from DOE, from DHS, from NERC. Those are good source of material, and they are being constantly updated. They provide a lot of knowledge that are practical knowledge. Then, of course, I also kind of mentioned several research papers along the way. They are useful from an academic research perspective. With that, I would like to thank some of my collaborators, several professors with whom I collaborate regularly on various research projects at Iowa State and also from other places. Actually, some of them graduated, my former students. They work in different places, government labs, and also sponsors, NSF, National Science Foundation, Department of Energy, Department of Homeland Security, Electric Power Research Center at Iowa State, and PCERC, which is a research center, Industry University Research Consortium, and of course, University of Minnesota and Professor Ned Mohan for this opportunity. And I also closely work with the IEEE PES Society, Power and Energy Society, in that cybersecurity task force. We organize a lot of panel sessions, some special issue publications. It's a forum that is used for sharing knowledge and so on. With that, I would like to thank all the audience who are participating online for your time and interest in this topic. If you have any specific question, please write to Professor Ned Mohan. I would be happy to answer, write a written response at a later point in time. With that, thank you very much.
Yeah. Thank you very much, Manuel. Thank you. Very interesting. Thank you. Yeah, fantastic.